We're now up to episode 8 of the battery-damaged Contax 137MA repair series, and it's finally time to tackle the elephant in the room, the main PCB. The bottom PCB is simple enough that I'll just replace that with plain wires, whereas the main PCB is quite a beast. It has an added complication in the fact that the rigid shutter speed PCB is permanently attached rather than being soldered in place. Actually, I figured out much later that it is indeed soldered to the flexible PCB, and I could have done myself some favours if I'd have removed it at this stage. The rigid part has these resistive sections that are presumably screen printed over the copper tracks, but the sections covering the copper tracks had lifted off with the alkaline contamination and just washed away. I haven't checked to see if there's still any electrical connection, but even if there isn't, so long as I can measure their values, I could probably remote mount some resistors to do the job instead. It's unlikely that this variable resistor will have survived, so I'll probably need to replace this, if I can figure out what value it should be, and if I can get a suitable replacement. Lastly, where the worst of the corrosion has taken place, it has potentially spread between tracks, and there may well be some shorts or partial shorts, so even if I use jumper wires to replace damaged tracks, I'll need to sever the existing tracks before the corroded section. So I think my first task will be to clean up the bad areas, examining them closely in the process, and then probably just give up and run away. I could of course redraw the entire PCB and get replacements made by JLC PCB or PCB way, but that would take a huge amount of time. I'd need to learn the PCB design software first, and I'd need to successfully remove the existing components from this board, and I still don't know if the chips are any good as it is, so I'll go away to start the cleaning and I'll report back in a bit. Well, it's all cleaned up, and I wouldn't say that it looks better as such, but it definitely does look a bit less bad now. The printed resistors on the shutter speed board are still making contact with the tracks, as far as I can tell, without separating the board from the flexible PCB. Even the two adjuster pots look like they might be working, but again, without isolating them from the PCB, I might be measuring something else. As a general rule, I don't like trying to measure components while they're still in circuit. I'll have to go through the board and check the continuity of any of the damaged tracks, because this one down here looks totally corroded, but it still makes a good connection to its 3 solder pads. So I'll go away again and see how many tracks I think will need replacing. I started trying to draw the entire circuit diagram, but soon realised that it would take forever. So for now I'm just going to draw the severely corroded sections. This area down here looks really bad, but none of the tracks are shorting and all have continuity. However, that's only testing them with the multimeter. Under load, things might be different. This section coming off the shutter speed board is the first definite failure. All 5 tracks are broken where the flexi PCB bends. My vague plan is to lay lacquered copper wire over the board where the tracks are gone, or are suspect, clipping it in place with tweezers and gluing it down with nail varnish. Once in place, I can strip off the lacquer at the ends and solder the repair in place. For the power tracks, I'll need to use a thicker wire or several strands of a thin wire. So I'll carry on checking and drawing and return once I've made a bit more progress. It's now been over a week since that last section was filmed, and I've probably checked enough of the flexible PCB to have an idea what needs repairing. Over on this side, as with the first side, most of the tracks test OK with no shorts or breaks, but there's a failed via which transfers the power from one side of the board to the other, which should connect this capacitor to ground. The capacitor is only there for noise suppression, so it would probably work without it, but I'll just reroute it to somewhere else on the board. As with the other side, I'll beef up some of the badly corroded tracks with a few bridge wires and then think about how I'm going to test this thing. And that's the first side done. The track that distributes the positive side from the battery was looking a bit fragile, so I've laid a fairly substantial enamelled wire over the top, soldering it to the transistor here, the capacitor here, and this pad that both feeds the bottom leg of the chip and I think goes all the way up to the transfer switch. Then I've popped in another wire from ground up here, round the chip and onto the other side of that capacitor to replace the broken wire. Where the wire crosses the others, I've added a couple of layers of Kapton tape, which should hopefully prevent them from rubbing through the enamel. The nail varnish I used on my first test example was a little weak for holding the wires in place, so I've upgraded to one of those UV curing glues, just to prevent them from lifting off the board. And now on to the more tricky side. Well, I was right about that being tricky. I've reconstructed some of the tracks on this lower section of the board where the worst of the corrosion was. It might have been okay leaving them as they were, but I didn't really want to rip the camera apart again if that wasn't the case. The section coming off the shutter speed PCB just fell off and was beyond repairing, and the fact that I somehow misplaced it is just an added annoyance. 3 of the wires I can easily reroute to another point on the board, but one just goes to one of the resistive tracks on the reverse side of this board, with the other going to an inaccessible leg on a chip. So I struggled for ages to successfully attach wires to each track. I'll just have to be careful that I don't break these while I'm installing everything else. Next, I'll crack on with reconstructing the bottom PCB, and then I guess it will be time to reassemble the camera. I thought to myself that making the bottom PCB wouldn't take that long. I was wrong. But here is the enamelled wire, Kapton tape and clear acetate sheet monstrosity in all its glory. Hopefully it will be slim enough to fit in the space between the camera body and the shutter mechanism, otherwise it will be back to the drawing board. And with that done, it's time to start the exciting part of reassembling the camera. Except it isn't, because I still have to fabricate a replacement wiper for the shutter speed selector. Will this project ever end? My plan for this is to draw out a template and recreate the wiper section, then use the existing stakes as location points, cut off the old contacts and solder the new one onto what's left of the original. So I'll get drawing and report back once I have something to show. Well, that's my design done, and I'm going to print out several copies because I doubt that this will work first time round. Ideally the part would be punched out, but that would require a tool being made. Alternatively, etching it would work, but I'd need to get some photo etch resist if I was going to go down that route. So I'll carry on with plan A for the time being. I'll lightly dot punch the 2 mounting holes along with the 3 contact dimples before pressing a blunted nail into the brass to expand the dimples. I've already done a few test dimples on the edge of the brass sheet so I can judge my pressure. I want the contact dimples to be as smooth as possible so they don't chew up the PCB beneath, so I'll polish them until they're nice and smooth. And that's the easy bit done. Now to figure out how I'm going to cut between the contacts. The gap is about 1mm and I don't have any tools that fine. I'm still not sure how I'm going to do this, but I've drilled a series of holes in the hopes of joining the dots. I have cut this brass sheet using a craft knife in the past, but that was doing straight lines with a ruler doing multiple passes, rather than this curved cut. Well, it's not exactly pretty, but it might just work. I ended up slicing between the drill holes with a knife, then used a fine round file to open the gap. These seem to be sold as welding tip cleaning tools, among other things. Not great, but it did the job, eventually. What I didn't show you on the day was the fact that while cutting the slots between the contacts, I managed to insert the end of that fine file underneath my fingernail, and you can still see the mark here a couple of weeks later. But at least it doesn't hurt anymore. I'll need to tweak the angle of the dimples when I come to install the wiper, and maybe do a bit more cleaning of the edges to make sure the correct part contacts the PCB. So next I just need to solder it to what's left of the wiper. How hard can it be? Actually, that bit was quite easy. The locating holes worked perfectly and it just sank down into position when I heated the solder. I may still need to tweak the contact positions, but I think they're about right. And now, finally, after what feels like an eternity, it's time to start reassembling the camera. I'll have to refer to my notes, but I think the first task is reattaching the main PCB to the mirror box. So I'll muddle my way through that and return shortly. That was all somewhat fiddly, but the main PCB is back attached to the mirror box. I put a lens on to make it a bit easier to handle. I'll still need to realign the shutter speed LEDs once the camera is powered, assuming it works of course, which I doubt it will. I'll get this lot reassembled onto the body and then add the remaining jumper wires that will replace the missing section of PCB. I think it would be reasonable to say that this camera is pretty fiddly to assemble. Just figuring out the routing of some of the wires has taken ages looking at shots I took when I dismantled the camera all those weeks ago. Anyway, it's now time to reconnect the wires from that bit of flexible PCB that fell off and I lost. These two that I managed to solder to the old tracks go to the two pads here. The upper pad on this side goes to the right hand side of this variable resistor, with the middle pad going to the left hand side. And the final pad needs to be connected to a pad on the underside of the speed PCB that I've already installed, so I've got to pull this lot apart again to do that. Okay, that's the first three wires in place. I'll put a bit of Kapton tape down and then lay the two fine wires onto their pads and hopefully that part will be sorted. And that's it done. It's not pretty, but it'll do. And now a little further on, with the ISO wiper and exposure compensation plate installed, along with the shutter button PCB on the other side. So next I think it's time to tackle soldering my Franken PCB onto the main PCB and connecting up all the other loose wires. As you might imagine, this was somewhat fiddly, with the wires of my homemade PCB needing to be teased into place, not to mention trying to make sure I connected the existing wires to their correct pads, along with the reluctance of some of the more corroded pads to accept any solder. But here is the camera, more or less reassembled, enough to try it out. Of course I still have to cobble some new springs onto the battery box, so I'll just get that done and then we can return for what will probably be the very disappointing climax to this video series. Well, that's the two springs attached, and a third one probably just about to knock the International Space Station out of orbit. But anyway, I'll now get the camera and audio recorder set up, ready for the thing to go pop when I power it up. So now for the culmination of about 3 months of work. Will it work or will it go pop? Here goes. Or will it do nothing at all? Well, that's a bit disappointing, but hardly unexpected. The battery check circuit is working, so at least that's something, but apart from that it's completely dead. Unsurprisingly, pressing the shutter button does nothing either. Well, after that monumental failure, I'll end the video. I hope you enjoyed this repair series, and I'll see you soon with something else. Okay, you didn't really think I'd leave it like that, did you? After that I got the oscilloscope out and did some probing, and it turned out that none of the chips were getting any power. Now call me old-fashioned, but I thought that the supply of electricity was a fundamental ingredient in the functionality of a chip. So I started stripping parts off so I could look at bits of the circuit board. Turning on the power switch just connects battery minus to ground, but this doesn't supply the chips themselves. They get a controlled voltage of about 2.7 volts supplied by a voltage regulator situated on the underside of the shutter speed PCB. Or at least I think this is what supplies the chips. I could really do with a full circuit diagram, but I guess I'll just have to muddle on without it. Tracing the circuits with the board populated is very tricky, so I've popped the voltage regulator out, partly to try to identify it and partly to see the tracks beneath it. This transistor on the same board is listed as the power on transistor, and I believe that this is the one that should switch the power to the chips. A little more checking later, and one of the tracks leading to that transistor passes through one of the joints between the flexible PCB and the rigid shutter speed PCB. I knew these connections were vulnerable, but I'd checked a few of them when I was working on the PCB and they tested okay. However, every time I move the board it puts more stress on these joints, and if we look closely you can see the green corrosion on several of the tracks. The one in question now tests as open circuit. This means that I have to scrape through the plastic of the flexible PCB to expose the copper track and solder in a replacement section. I've already done the first one, but I'll do the rest and then maybe try to power up the camera again. Well, that job reached new levels of not fun, but there are the 5 tracks reconnected. I guess I'll reassemble the thing and try again. But if it fails this time, I'm really going to end the video and put this project on one side for a while. So here goes for the final attempt. Nothing. Not even a power on LED. And after a bit more probing, there's still no power going to the chips, which is a bit frustrating. I'm going to walk away from this project for a bit before it drives me crazy, but I will return at some point. If you've enjoyed watching, please like the video and maybe even subscribe to the channel, not forgetting to click on the bell icon so you get notifications when a new video is released. That's it for now, so thanks for watching, and I'll see you in a future video.